Good afternoon to everyone. Respected speaker of today's webinar, dignitaries and delegates of today's session, I would like to extend a very warm welcome to everyone. Today, we have gathered virtually for the webinar on Docker Technology hosted by Department of PCA, Cayley Society's Degree College, Nagarabhavi. Before proceeding further, I would like to share few words about Cayley Society and our department. Karnataka Lingayat Education Society, started in 1916, occupies a very special niche in the field of education, has now grown into a large institution that encompasses an autonomous university and over 270 institutions spread across the country and outside with over 16,000 employees working to cater the needs of more than 1,25,000 students. The collaborations with universities in the US, the UK, and Malaysia have added a whole new dimension to the Cayley Society, making it on par with the reputed educational institutions worldwide. The Department of Bachelor of Computer Applications was started at Cayley Society's Degree College, Nagarabhavi in 2017 with the mission to provide high computer education to the students. The institution grooms its students to excel as future ITians. We have plenty of learning opportunities for our students. We are associated with ICT Academy, VIPAT, Oracle, Palo Alto, AWS Academy, Microfocus, and Salesforce. Today, we are hosting our 5th webinar of Cloud Arena webinar series. The speaker of today's webinar is Ms. Aishwarya Saraswathi, HM, Consultant for Supply Chain Services, IBM India Software Labs. She has been a part of two of the largest retail company projects, solving the order management and fulfillment problems. For one of the projects, she has infused AI-based framework to ease the jobs of customer care representative. Whereas in the current project, she is a performance consultant for supply chain services, working on infusing recent technologies for performance, tuning of order management and fulfillment systems to meet the customer's non-functional requirement. Now I request Ms. Aishwarya Saraswathi to represent her talk. Over to you, Madam. Aishwarya. Aishwarya, unmute yourself.
Yes, sorry. Hello everyone. Thanks, Arpita ma'am. Good afternoon everybody. Hope everyone are safe and healthy and stay inside your house. And thanks for the introduction. So a few things about me. So it's been two and a half years right now working for IBM Technology. 6 months I worked as an intern over there. And later on I absorbed. So as you all know, today's topic. So going forward, it's Dockers. Let me share my screen. Hope everyone can see my screen. Arpita, yes. Can you just verify?
Yes, it's clear now.
Yes. So, let me start from the scratch. How these Dockers started. So before this Docker, it was actually, before going forward, we'll go for the contents before. So today's contents that I'm going to cover is virtualization, containerization, virtualization versus the containerization, history of container technology, what is Docker, Docker architecture, why Docker, when do you need to use Docker, installing Docker, Docker commands, and if time permits, we'll also cover this Docker file as well as the Docker compose. So the very first topic is virtualization. So this is the very first step of the Docker. So we'll see what exactly is virtualization. So just to read the points over here, let me go. It refers to importing a guest operating system on a host operating system, this allowing developers to run multiple OS on different VMs while all of them run on the same host, thereby eliminating the need to provide extra hardware resources cheaper than the previous methods due to less compact infrastructure setup, easy to recover, and do maintenance if there is any failure state. So just to give some examples, let me tell you one small thing. Okay, so think that you have a laptop, you are using this you have a Windows operating system. If your lecturers or any of your colleagues, or if the project demands you to work on a Linux operating system, what would you do? So if I remember, in my olden days, we used to have a partition the hard disk, having a separate Windows OS as well as having a separate Linux OS, dividing 50% of the hardware disk. That was like previous. Now we have a virtualization. Can you just let me know who and all knows about the virtualization? You can ping on chat. So let me know if it is yes or no. What is if you know about the VirtualBox? What is VirtualBox? Yes, I could see two replies. So yes, VirtualBox is not a cloud space. So it's a software. So where we can actually, this VirtualBox is nothing but a hypervisor. I'll tell you what exactly the hypervisor is later on. So this VirtualBox can have its own. We can actually install our own operating system through ISO files. ISO files is nothing but image files. We can have our own Ubuntu OS. We can have Red Hat OS. We can have CentOS OS using my laptop, which has a Windows OS installed. So this is what the VirtualBox is. Yes, I think Prajwal replied, software we can run any OS, right? So that is where the first point tells. So these VMs, what I told, the Ubuntu, the CentOS, the Red Hat OS, which is actually on my Windows OS, these are my guest OS, whereas my Windows OS is my host operating system. So the next is, so the second point actually tells we can run the multiple OS on different VMs while we are running on the same host. So this is very cheaper, because the previous, as I already told you, we used to actually divide the partition to work on a different OS. So like, as I told you, like 50% I need for 50% of RAM I need it for Windows OS, 20% for Linux OS. So this used to actually, there was a huge hardware resources consumed all over there. But virtualization, this eliminates the provide for the extra hardware resources, and it is also a cheaper one. So it increases the ID productivity, efficiency, and the response. So the next slide, going for the next slide, this architecture. So let me have a highlighter. So if you see, as I told you, my Windows OS would be my host OS, whereas this hypervisor is nothing but the VirtualBox, which I gave you an example, and these are my VMs. So here, if you see, I have 3 guest operating system working on my host operating system. So here, virtualization lets us run our application on few physical servers. Each applications and OS live in a separate software container called VM. So this whole thing is called a particular VM. So if you see, so this has bins, libraries. So each VM would be having its own kernel, its own guest OS. It has to install its OS, everything. So and where VMs are, so what is hypervisor here? So hypervisor is nothing but which creates the VM and manages the VM. So it actually, provides the resources that is necessary for these VMs. So this is about the virtualization. We'll see what are the drawbacks of it. So drawbacks: running multiple VMs over the same host leads to performance. So I'm a performance consultant as well. So I can say that, so as all these VMs are on my operating system, so it will impact the performance. So yes, later on we have some, I can show you few things. I can show this also, how it is, there is a delay in the performance also, while, on click of a button, you have to wait at least for seconds. It's not in milliseconds or in nanoseconds, which is, the performance is very faster. So that is the first point. The second is, as guest operating system have their own kernel, libraries, and many dependencies running on a single host, it takes up a larger occupation of resources such as processors, hard disk, and especially its RAM. This is one of the drawbacks. The next one is using VMs in virtualization. The bootup process takes a long time that affects the efficiency in the case of real-time applications. I can show this, but it will take 2 to 3 minutes to just open a particular VM. So I have already opened, so let me show it to you later. But when you click on this VM, for example, in my VirtualBox, I'll go for this Ubuntu. I want to work on Ubuntu OS. When I click on that, it will actually take literally 2 minutes to 3 minutes to open up the the desktop. So the boot up time is very less. It takes longer time. It's not efficient. So that is when this containerization picture came into. So what is containerization? Containerization technique is nothing but we are virtualizing at the OS level. So you have seen that we are for virtualization, we are actually the whole thing is virtualized. You have guest OS, you have bins and libraries, you have application over there. But here we are just we are virtualizing at just the OS level. The whole hypervisor would be a container engine. There won't be any guest OS. You will be using the same host OS, using the same hardware resources, which is being, which is given to the host OS, and the necessary libraries and bins, which is necessary, which is, which is in demand for the particular application to run, would be containerized. So not the whole thing. That is why it is lightweight. So it would be more efficient because there is no guest operating system, as I already told you, which so it would be consuming only from the host resources, that is our host operating system, and share relevant libraries and resources only when they are required. So I told you that these required binaries, libraries would be packed into one container. So this is the third point which is telling about it. So containerization is a lightweight virtualization technology acting as an alternative to hypervisor virtualization. I told you. So this my hypervisor is nothing but a container engine. I'll show you the picture later on the next slide. So the boot up time is very less. It would be in seconds. This, when I'm running the Docker images, I can show you how fast it is to start or stop the containers. And it exhibits high performance because it is using very less resource utilization. It is using very less resource like CPU, like memory, networking, everything. This is a image. So if you see over here, so this is my host OS. So this is my container engine. Host OS for me is nothing but my Windows OS. Container engine would be my Docker. Just giving a one of the Docker container engine is Docker. So Docker, and these are my containers. If you see, we don't have guest OS underlaying over here. So that is why it is very lightweight. So coming to the difference of virtualization versus containerization, we'll see what are the difference. We already discussed, just briefing out. So virtualizes hardware resources, whereas containerization virtualizes only OS resources. Virtualization requires a complete installation of operating system on each VM. So as I said, in VirtualBox, if I need Ubuntu OS, I have to install Ubuntu OS using ISO files. If I need to if I need to operate in Red Hat operating system, I need to download ISO file for Red Hat and then install it in my other VM on the VirtualBox. Whereas the containerization no needs for any operating system. Instead, it is the only host operating system which my laptop has, that is my Windows. Next, a kernel is installed for every virtualized OS. So it is very necessary when we install OS, kernel should be there. But here, as we don't have guest OS, no need to use, no need to have a separate kernel for each containers. Instead, the host only has one kernel, that is my host operating system, that is my Windows. It's heavy weighted, it's lightweighted. I already told why it is lightweighted, and limited performance because it is using huge resources, whereas it is the performance is native because it is using very less resources. This is fully isolated. If you want to go for fully isolated, as in you can't access files, files, anything from my Red Hat operating system. You can if you want to access these files from Red Hat operating system, you need to log into Red Hat open operating system and get the files. And if you're working in a Red Hat, operating system, you won't be knowing what exactly are there in the Ubuntu operating system. But here, everything the containers can communicate, only the isolation would be at the process level. So this is how it is. So if I have to say server, so we have host OS. So here it's hypervisor, whereas here it is my container engine. So here I have a guest OS. This whole thing is my one VM. Let me mark it. So this whole thing is my one VM, whereas this one is my other VM. But here, this is my one lightweight container, and here the other lightweight container have sharing the same operating system. This container engine will give the resources which is necessary for these containers C1 and C2, which is dynamically through this through my host OS, whereas this one would be having its own. This is my V1, V2. So this hypervisor would actually give a set of resources to this and set of resources to this. It is not dynamic, by the way. So this is about the virtualization and the containers. So next, see about the history of container technology. For this, I have, just to make sure that you people are not sleeping, I have a small quiz for you people. So we'll see how many people can answer. So you can use your chat box. It's a multiple choice questions. One is not multiple choice question. You can actually just reply in the chat. We'll see who will get it first. So for each question, we have 30 seconds, maximum 1 minute I can give, and then I'll be moving to the next question. So the first question is, can you see my question, everyone?
Yes, it's visible.
Yes. So which company logo it is? Oracle, Linux, FreeBSD, Redis. Yes, we'll see what's the answer. So it is FreeBSD. Yes, Thomas CG, you got it right. So BSD. Okay, so this quiz actually tells about the history. I don't want you to bore with the history, so I have taken with the fun part of it. So what is the part of FreeBSD in the history of container technology? On March 4th, 2000, FreeBSD introduced the jail command. Jail command is nothing but similar to chroot command. It includes additional sandboxing feature to isolate the file systems, users, networks, all these things. I don't want to go further on this. You can always Google for the history of it, but I'll just give the points how these companies were a part of these container technology. So the next question going forward, what is the name of penguin character in Linux kernel? So we'll give 30 seconds more, we'll see. Yeah, I think most of them got it right, huh? So Tux, right. So Tux, so how Linux was a part of it. The Linux vServer was a solution provided by this Linux team to separate the user space environment to distinct units, virtual private servers, what they call, in such a way that VPS looks and feels like it is its own what we call the real server. It's isolated within. The next question is, we'll see. Which company developed Solaris Unix operating system? Is it FreeBSD, Google, Sun Microsystems, or IBM? Okay, so I think Ali Ansari, you got it right. It's Sun Microsystems. So it was a third company, which was a part of this, the whole history of it. Solaris containers are created for full application environment through the use of Solaris zones. With zones, you can give an application full user process and file system space along with access to the system hardware. However, the application can only see what is within its own zone. So this is the company Sun Microsystems, which created the Solaris containers, which was like, it had its own zone. It was like totally isolated. So if I have already told you, gave these examples to you, right? So we used to have the, partition the hard disk so as to make sure that we can use both the operating system. So this was the time when those things happened. Next, we'll go to the next question. Okay, so this is tricky. So don't be evil was which company's motto? Is it Oracle, Google, IBM, or Linux? So read the question properly. It's don't be evil was which company's motto? Thomas CD, I think you got it right. It's Google. So Google right now has this motto: it's do it right thing. It's not don't be able. It was before, but right now it's do it right thing. So Google was the next company which was part of this history. In 2006, engineers at Google announced their launch of process containers designed for isolating and limiting the resource usage of a process. In 2007, these process containers were renamed as control groups, which is known as C groups, to avoid the confusion with the word container. So instead of confusing it with container groups, it's not like that. It's controller group. That's why they have introduced this word, this phrase. The next company which was a part of it, I don't have MCQ for this, but let me see who can get it. Name the company. Yeah, it's pretty easy, right? I think Muralidhara got it right. It's Red Hat. So Red Hat adds a username spaces limiting the root access in containers in 2008 after what the process containers that they have introduced. So next question, what is IBM full form? So let me see who will get it right. Is it Indian Business Market, International Business Machines, or just IBM, or International Business Market? Okay. Yeah, it's like most of them got it right. So it's International Business Machines. So the next thing, so yes, IBM was part of it for this history of container technology. So they have created a set of engineers from IBM created this Linux container project, working with Linux. So they added a layer, user space tooling on C groups and namespaces, while this LXC provided an improved user experience around the containers. So I think the last one, so which company has this logo? A shark. And you have all these containers over there in the picture. So I think Thomas got it right first. It's Docker. So if you see, it's like a ship carrying the containers. So this ship is a container engine. So this container engine for our webinar, it's a Docker, right? So Docker is a container engine over here, a ship carrying all the containers. So that is why they have this logo. So we'll see, it was introduced in 2013. So Docker, both the technology and the company, started off this public PaaS, that is platform as a service offering called .cloud. So this PaaS solution benefited from container technology, which brought new capabilities such as live migrations and updates without interruption. In 2013, .cloud open sourced its underlying container technology and called it as a Docker project. So this is a brief history about container technology. Hope you people are not bored about the history. I tried to bring the fun over here. So we'll see what is Docker as we reached to this point. So in simple words, Docker is a platform used to containerize our software, using which we can easily build our application, package them with the dependencies required into into containers. These containers are easily shipped to run on other machines. So in simple words, Docker is a platform using this, four keywords: containerize, build, package them, and ship it and run it. So sorry, it's 5. So whatever the software you want to build, containerize it, and if you have any, and build that particular thing, build that particular image, then package them with whatever the necessary libraries, bins, dependencies which is required, and then ship it. Okay, so what is ship here? So if I need this Docker image to be sent it out to maybe Arpita ma'am or maybe some other person on this thing, I can containerize and give it to you, and you can actually install it and run it. So it's shipping the whole containers to other person and run it. It is as simple as that. So what is Docker architecture? So we'll see some architecture, like going deep into theory part. Come on, zoom it. Yes. So we have three things over here in the Docker architecture, that is client, Docker host, and registry. So client, the whole architecture follows this client server architecture. So client has three things: Docker build, Docker pull, Docker run, whereas Docker host as Docker daemon and the Docker objects. Docker objects, we have two things: containers and images. So these two are known as Docker objects. Whereas the other one is registry. Registry is nothing but the public repo or a private repo. So the repository, something like GitHub, you can say. It's an example. We have separate for Docker registry. We call it as Docker registry. So here, so client, these, wait, let me mark it. Let me take the highlighter. Sorry. Yes, so this client interacts with the Docker daemon and can be, so this client can be interacted with Docker daemon so as to build a particular Docker image and run it and distribute the containers all over. So Docker client and Docker daemon can be operated on the same system, or otherwise you can have it Docker host in some other remote system. Both can communicate with REST API. So using this Unix sockets, as you know, over the network. So if you see here, so the black lines are for Docker build, orange lines are for Docker pull, whereas the green lines are for Docker run. So what it is doing, this client is nothing but, it has a command prompt. You can run these Docker build, Docker pull, Docker run are the, what do we say? It's a commands. So you have to run Docker build. So what exactly, when you just give it, so it will actually interact with the Docker daemon, and Docker daemon in return, if you have Docker, okay, so Docker build can be used only when there is a Docker file. So these are Docker files. So if you give Docker build, it will communicate with your Docker daemon, and in response to that, it will call this Docker file. So once you build, what do? You'll run it, right? So that is where the green lines comes into picture. So Docker run for this particular Docker file, what it does, it runs this particular image of Docker file, and here it will create a Docker container. Next, Docker pull. Docker pull is nothing but when you have an image in the repository, like GitHub or something, you actually need to, run this particular command where Docker daemon speaks to the registry and pulls that particular image into Docker daemon. And if you want to run this particular image, you need to use this Docker run command so that this will be created into containers. Hope everyone got it, proper. I mean, you understood. I'm just speaking in layman words. If you really want to, understand in better ways, I can speak something like, this Docker daemon is nothing but the brain, like in a human being. So if you want to pick some object from your hand, so what does your hand do? It will send a set of instructions to your brain, right? And what does the brain do? Brain will send a set of instructions to your hand telling that you need to go, you move your hand and collect the particular object. So that is how it works. The Docker daemon is a brain of whole Docker architecture. Let me see if you have any questions or something. Okay. So the next thing, just deeper into this Docker client. So what is Docker client? So as I already told you, it's just a command prompt. You just have to run it. That is what the Docker client is. It will interact with your Docker daemon. It's as I said, it's a command line utility for other tools using Docker API to communicate with Docker daemon. A Docker daemon client can communicate with more than one Docker daemon. So this is, I think it's pretty straightforward. I'm not wasting time on this. Next. So Docker host. So what is Docker host? As I already told you, Docker host has Docker daemon, Docker objects. So Docker objects is nothing but the containers and the images. Docker image is, in a simple words, again, a layman words, what do you do if you want to cook a separate, master chef kind of food or something? You'll follow a set of instructions, right? You'll follow a recipe. Similarly, this Docker image has a set of instructions to create an image. So create a container. So that is what the Docker image is. So it has a set of instructions to be followed. For example, it has to have the base image, it has to have its own, it has to run this particular command, it has to copy from these. All these things would be there in Docker image. So that is what it said. Includes steps for creating the necessary softwares. Docker image is a type of recipe template that can be used to create Docker containers. So what is Docker container now? So Docker container, a type of virtual machine created from the instructions found within the Docker image. So as I told you, when you have a Docker image, what it does, so when you're running that particular Docker image, it will be converted as Docker container. So it is a running instance of a Docker image that consists of entire package required for an application. So if you want to run a particular application, so you may need some libraries, dependencies, all these things, right? So those things would be there in this Docker image. It tells that I need this particular dependency for this particular software to run. I need this. So that is when it downloads only if it is necessary. So those things you can provide in the Docker image. So going forward for the next slide, so we have Docker daemon. So what is Docker daemon? Docker daemon helps in listening requests for the Docker API, in managing Docker objects such as images, containers, volumes, etc. Daemon is used to build an image based on user's input and then saves it in the registry. Docker daemon can communicate with daemons to manage Docker services. As I already told you, so this works as a brain. So it has to listen to all the requests. It has to give the response to those requests. It has to build image, build image as in build a set of instructions so that it can make sure that the Docker image is run up and running. So it's similar like brain. You can just have a comparison. So what is Docker registry? I told you that Docker registry is something like GitHub. So you can it's nothing but a public repository where you have all the images, the common images like Ubuntu, like even a small Hello World program. All these are stored in a public repository called Docker registry. So we have so many registry like that, public repositories, and you can always have a local or the private registry or the in the Docker Hub. So what is this local private registry? So why do you need this? So maybe your project demands for the it shouldn't be shared for other people. If it is a public repo, obviously other people can pull in who is not a part of your project or who is not your part of a company or not your college. So you should have a private registry, right, where you can actually save all these things to maintain the security and other issues. So that is why we have a local and private registry. So there is a video. Let me show. It's simple, just 2 minutes. We'll see how it goes. Let me know in the chat if you can hear it or not. Okay, so I think maybe there is some issues in settings. Okay, let me run at the last. It's just 2 minutes. Maybe I can run at the end of this session. So coming to the next slide, why Docker? Why do we need Docker? So we'll see. So some of these, why do we know Docker is nothing but the advantages of Docker in a simple words. So Docker is fast, unlike virtual machine, because virtual machine takes maximum boot up time, whereas Docker is, the containers are very quick. It is in seconds. Docker is multi-platform. I can say something like if I am running in Windows OS and if I need to share the Docker image to one of the other person of my colleague and he is using the Linux operating system, he can always run. So it's a multi-platform. Containers can be built and destroyed faster than the virtual machine. So if you see the virtual machine, it's very heavy. I'll show you how much. I have one snapshot of virtual machine. You can see it's around 3 GB or 4 GB, whereas these containers, it would be in MBs. It's very less. Containers can be built and destroyed faster than the virtual machine. That is why it is very, it takes time to delete. No more difficulty setting up the working environment. As I told you, if I have a new colleague who is coming to my team, so what I'll do, I'll set up my work. However, I'll be having my working environment. I'll create a Docker image of that and give it to my my new colleague. So my new colleague can have her or his own working environment in a minute or so. Not in a minute, in a second actually. So you keep your workspace clean, as each of your environment will be isolated and can be deleted them at any time without impacting the rest. So if you're deleting some dependencies, you can, because it is not affecting the other Docker images. So you no need to worry on that. And it will be easier to deploy your project on servers, that is cloud, anywhere. So when do you need to use Docker? So I have three basic things. So one, for replicating the environment on your server while running your code locally on your laptop. One for CI/CD, there are a number of phases on your projects. So that is when you can use Docker. For distributing your app OS, I mean the application operating system to your team, you can use Docker. So these are three basic things when you can think about Docker, that yes, I need Docker at this point. So Docker installation. So let's see how to install Docker. I have created few things. Mm. So this is virtual machine, by the way. So I told you I'd show you how the virtual box looks. So this is my virtual box manager. And I'm using this because I don't have space in my laptop and my project demands to have these images created in our separate VDI, what we call. So that is why I don't have Docker installed right now in my Windows OS. I have in my other things, not here. So that is why I want to use a Linux operating system. That is why I'm taking a help of VirtualBox. Can you see my screen?
Yes, ma'am. It's visible. I'm sorry, there was a technical glitch. We were disconnected for some time, a moment before.
Oh, okay. So
Yeah,
can you hear me now?
yeah.
Yes.
Yeah,
So you
yeah.
can see the virtual box, right?
Yes, like it's
Okay.
Docker installation. That is what.
No, not that one, not that screen. One second. Let me share the other screen then. Virtual box. Sorry for the delay. Just hold on for 2 minutes. Let me open that. Yes. So this is what we call as the virtual box software. So if you see, I have few installed things. This is my Ubuntu Maven. So this has my just Ubuntu, nothing installed over there. I have Maven installed over there. I have this is my IBM thing. So OMS training that we work for. This I created for today's demo. So we'll see. So this would take some at least what do we call 2 minutes to open. So that is why I already opened it. So let me share my other screen. That is my VDI. Let me know once you people can see my screen. Can you see the DevOps, the login thing? The password it's asking for? Yes, cool. Just notice the delay time that it is taking, okay? So it's taking a much longer time. I hope you can see my command, the terminal now. Okay. So I wanted to know if I can share all my screens together. Is it possible in Zoom? So can you see my PPT right now? Okay. Sorry for the delay. It's okay. We'll see how it goes. So okay. So this is my sudo apt update. Sudo apt install. So these are the steps of what do we say, the commands that we need to install it. So we'll do one thing. We will right now install it. I won't share the screen as of now. I'll be just sharing my VM. However, I will be just moving screens by screen just to copy those commands. Hope it shouldn't matter. So we have a command. Docker file. Docker installation. So sudo apt get update. So we have some security issues. That is why we have given as sudo user for each and every time that we work. So it is updating all the necessary, what do we say, upgrades which is necessary. Next we have sudo apt install this one. Let me copy and paste it. So it's downloading all the dependencies. This is just few steps installation, so you can always do it. Once it is done, we have so it's taking time to install. Let me figure out if meanwhile I can download, click on share all screens. I don't know where exactly the option is to share all screens. I can see just my opened files. I don't have the option of share all screens when I click on you share. It's okay. So we'll see. We'll just wait this to complete. It's taking time to install. Maybe some network issues from my side. So the next command, we have curl command. Yes, so it's properly added. Next we have so these commands are taken from Docker, what do we say, installation proper, its own official website. So you can always go through that to install it. It's pretty straightforward. So I'm using the same thing. So this it is to create a repository, a local repository in my VM. So this is done. So what is the next step? So next we need to update again because we have created the repository. So we need to update all the necessary dependencies. So let me do it. So after this, we have to install Docker. All packages are up to date. Yes. So now I'm trying to install. So it's install Docker C. So unable. So let me figure out. There is one thing that I need to do it. Just give me 2 minutes. So we don't have container DB file here. So that is why it is throwing an error. So let me install that. Sudo. So after that, we need to install this container.io file. So once this is done, paste. So once this is installed, we should be able to download Docker. So it created symlink also, so no need to create that one. Now we'll install Docker. It should install, yes. So next, just to check whether it is properly installed, we'll just check, do systemctl. Yes, it is running. If you see the green dot Docker application container engine, which is green dot, it's properly running and it's active. So we are good to go now. So next, so we'll check Docker version. So version is 1903. It's proper. Few things. Let me tell you. So we are done with the installation part. So let me share my PPT screen right now again. Yes. So the next step is, what do we do? Docker commands. So we'll see how Docker commands are. What are Docker commands? Let me open the presenter view so that I can go back again. Yes. Hope you people can see my screen. It's not very small. So Docker run. So we have few commands, very basic commands. Docker run runs a command in a new container. Docker start starts one. We'll just go through few of these commands later on. Docker stop to stop the container. Docker build, as I already spoke. So it creates an image. It builds an image from the Docker file. Docker pull is nothing but pulling the image from the repository. Docker push is nothing but if you have created something unique and you want to push it in the repository, then you can use this particular command. Docker exports is to create that particular image in a TAR format. So Docker executable, so to run that particular runtime container. Docker search is to check the images from the repository. Docker attach to attach the running container. Docker ps to show the running containers. Docker image list the images. Docker load is to load the image from the tar thing. So now I'll show you some commands running right now. So we have this clear. So Docker images, we'll see the first command. Sudo Docker image. So we don't have any images. So because we haven't created one. So we'll do one thing. We'll see whether we have a running containers. Docker ps-a. Sorry, we don't. Sudo informators. Sudo. We don't have any containers. So very good. So now we'll pull hello world program from the repository. So Docker pull hello. Okay, we'll search whether it is there or not. So Docker search command. Hello world. Sorry. Sudo. Yeah. So yes, we have few. So let me take the first one. Hello world. So next, clear. So sudo docker what do we need? We need to pull, right? Pull hello world. Yes, it's pulling. So first it if you see pulling from the library hello world, so it's run. So we'll see how to run. We'll run that. Docker sudo docker. No, we'll see first images are there or not. Docker images. Sudo docker images we have. Now we'll run that particular thing. Sudo docker run. I'll just give the image ID, that is bf75. So hello from Docker. Yes, we got it, right? It's up and running right now. So this is the print statement that is inside that particular container. So you saw how fast it is. Did you see when I opened this command, terminal itself was taking time. It just took 30 seconds, but here it is how fast it is. So that is how it is. So now we'll see Docker ps-a. I'll just clear it. Sudo. So I can see hello command is running. Container ID is this one because we started this image, right? So that is why it is created to container. So we have it. Cool. So next, what do we do? We'll go to the next slide because we have some time constraint. So Docker file, we'll just create, we have time, right? Yes, we can create a Docker file. So going forward for the Docker file, there are few keywords which is a part of Docker file, but it is not necessary to be in the Docker file. By the way, Docker file is nothing but a set of instruction, like a recipe to follow. When we run this build command, it will create an image from the Docker file. That is what the Docker file mean. So it has add, copies the files from a source on the host into the container's own file system and set destination. So you don't need all these things, but let me show you few things. For example, the from. It should be there because it is setting up the base image. So you need this for the building process. Maintainer is nothing but who is running, just your full name, email address or something. If you want to set the environment variables inside the containers for a particular application, you need to give this env. Okay, so next we'll go to this. Run is nothing but what executive directory you need to run, user, these things are okay. But see, as I said, not all keywords are required for a Docker file to function. So small example, this is one small Docker file that we have. Ubuntu 18.04 is your base image that it has to install. Copy.app is nothing but, it has to copy that the particular folder to your working directory. Run or build the application by make command. Command is nothing but the Python file to run. So how do we run the Python file? Python, the Python file, right? So that is how. Let me show you one. I have we don't have time, so I have created already one. So when I have created all these files, let me show you what these files are for. I mean, what does it contains. So ls-ldr, so you can see that I have created a folder called docker build. So we'll go to that file. So this is my working directory right now. So it has one file. If you see, it's docker file. Clear. So we write docker file. We'll see what does it contain. Docker file. So if you see from Ubuntu, the latest version I need, maintainer, Aishwarya, and my mail address, add get update, upgrade, install, build essentials. Yes, we are good to go. We'll run this now. So how to run this? So I have a command to run. One second. Should be. So just giving the name as Ubuntu. So if you see sudo docker build command I'm using, I'm tagging it because I want my image name to be Ubuntu, and this the dot should be very important because it is the what it compiles everything. So welcome. So created. So we'll see now Docker images. By the way, this is different instance, so you can see multiple images here. So right now I created one, right? What does it mean? Ubuntu. I create the tag name is docker file. Image ID is this one. Don't go with the created ago these things because this I created this file ago. Yesterday, so it's fine. Yes, it's a root directory. So we are using dot because it has to compile all these dependencies. That is why we are using dot, and it's very important. You can check on this or what do we say, the official document of Docker. It will tell you everything. Okay, so this is one. Let me go through take you to Docker Compose. Docker Compose is nothing but where is Docker Compose? It's nothing but a particular software you just have to download first. So it has I don't want to go with that because I don't have time. I need to run for other meeting. So Docker Compose, you need to download for that. This Docker Compose, you need to create a YAML file which has a set of, so think that you have 10 Docker images. So if you want to run this all 10 Docker images, you need to run this Docker build 10 times. What if you have 20? You have to run for 20 times. That is why Docker Compose, you have to, Docker Compose, make sure that all these 20 containers which you want to run, make sure it is running in a single go. So I will show you how this works, okay? Docker Compose. So I have given few things. That is application. So I'm creating a Python file here. So if you see, so if you see, I have a Python file. It's just a Flask. I'm just calling it to my local host to get the count. So next I have VI requirement file. What and all softwares I want to. I need Flask and Redis. Redis is nothing but a message broker kind of thing. I need these things. That is what I'm saying. Next I have Docker file. Docker file. What do we have inside Docker file? We'll see. Docker file. So I have given Python. I need Python. working directory, environment Flask, Flask app, app.python. I'm providing the host. I'm exposing the 500. I'm running, telling that I need this requirement, like whatever the things that needs to be downloaded, like Flask and Redis. I need it. It's copying from the requirement. So this is how the Docker file looks. So now we will Docker compose. We'll see Docker compose. So this is how I'm exporting the path and the Redis image. So now we'll run this. Where is the Docker? No, I can run it. So it's simple. Docker compose. That's a YAML file name, right? Compose up. Yes. So if you see, it creates Docker web 1, Redis 1. So this server is up and running. If you see running on this local host, it is running right now. So let us open how this file looks. So this is localhost 5000. So I have already run this command for run this file for multiple times. So you can see it's the 6th time I'm opening this. So if you just refresh, it is a 7th time. That is what my app Python file is doing. So, and if you see here, let me open the other terminal. So if you see Docker images, we'll see sudo Docker images. Welcome. If you see, I have Python running, Redis running, so it is running, right? So we'll see if it is running up or not. Docker ps-e. Sudo docker -e. See, it's running, right? The Flask is running. If you see, so Docker compose web is running, Flask is running, entry point is running. So this is what the Docker is. So what if you're stopping the server? Obviously it won't work, right? Because the server is down. So we'll see whether this is working or not. If it is stopped, no, it's not working. So that is how the Docker images work. Let me. So it has a set of instruction to download the Docker compose. Just 3 commands you need to run: sudo docker compose version. Download it from the GitHub. You can change the permission mode and then compose version just to check whether it is running or not. And we have first create a directory for the project, create a requirement file in that directory, create a Docker file, create a compose YAML, run the Docker compose. It is as simple as that. So I think that's the end. So I think we are on time. So thank you, everyone. I think let me share you my mail address. If you have, I can't take the question answers right now, but yes, I'll be available on my mail ID. You can always ping me if you have any doubts. I can answer for that. I have pinged my mail address. You can just go through. Thanks, everyone. So let me stop sharing.
Yes, ma'am. Just a minute.
I hope everyone, it was not boring one. It was useful.
Thank you, Aishwarya. That was a wonderful and enlightenment talk. Now we have to come to an end of the session. On behalf of the management, the institution and the organizers, I thank speakers of today's webinar, Ms. Aishwarya Saraswathi, for enthralling the audience with your talk. Tomorrow we have another webinar on blockchain technology. Please do attend. I am thankful to Professor Vijay Kumar AS, Coordinator, Department of BCA, for successfully organizing the webinar. I thank faculty members of Department of BCA for helping to organize this webinar. The response we got for this webinar was overwhelming. It is our active participation which motivates us to conduct more webinars. From the bottom of my heart, I want to thank all of the participants for making this webinar a success. Thank you, one and all.
Thank you everyone.
Feedback link is shared. Participants are hereby informed to give the feedback to obtain the e-certificate.